Welcome back, ladies and gentlemen. In the video, we are going to be discussing how to find the interior angle sum of any given polygon. In the last video, we defined the formula and we kind of saw the pattern of n minus 2 times 180, where n is your number of sides. And what ended up happening is when you took the number of sides and subtracted by 2, it basically gave you the number of triangles that were found by making those diagonals. And that's where that 180 comes from in that formula. And so here it says we want a convex heptagon, Well, first and foremost, what do we mean by convex? Well, we have to take into account that the interior angle sum formula is only for convex. The reason being is because a concave polygon, for example, something like this, look how big this interior angle would be that I just kind of outlined. So we can't use it for concave polygons, but we have to use it for convex. So for convex heptagon, remember a heptagon means that n equals 7. The number of sides would be 7 for a heptagon. And we would take 7 minus 2 times 180. So that's really 5 times 180. And when we take 5 times 180, we end up getting 900 degrees. Now, personally, I think heptagon is one of those ones that you will start to kind of memorize a little bit, simply just because it can be common and used quite a bit. So some of the ones that I do think are going to be coming on up a little more frequently that might be good to start memorizing what is what from them is anywhere from a triangle to somewhere in that nonagon decagon range. So remember, for our triangle, we have 180. Add another 180, we get 360 for our quadrilateral. Add another one for our pentagon, we get 540. Then we get 720. Heptagon gives us 900, as we just said. For our octagon, we add another 180 for 1080. Our nonagon, we end up adding another 180. We get 1260. We add another 180, and we get 1440. For one more 180, we get for our un decagon. All right. You also may see this in a couple different variations. A lot of people actually simply just called it an 11gon. And some textbooks don't even represent 11 as un decagon, just kind of a fair warning. We get 1620. And then last but not least, for our 12-sided figure, we know it is our dodecagon, and that is 1800. Now, I'm not saying that you necessarily have to memorize these, but you will kind of get to a point where I think these ones are just used a little bit more in commonplace.